Okay, so let's do one example for activity crashing. Okay, so you can see this network has been shown over here, and it has been asked that the lowest cost to complete the project in 10 days. Okay, so let's look at what is the duration of the project, original duration of the project. So activity times are 3, B is 7, C is 5, D is 6, and E is 4. There are 3 paths in this network: A, D, A, C, E, and B, E. AD is 9 days long, AC is 12 days long, and BE is 11 days long. So from this information, we know that the original duration of this project is 12 days. So what we want is we want to reduce it to 10 days, but for the lowest possible cost. That means the increase in the cost should be such that it is lowest. Okay, so for this I think it will be better if we calculate the slope of each activity. For A there is no slope, so maybe if I add a column for slope over here, A there is no slope. No, because A cannot be crashed. B has a slope of 50, so it should be minus 50. C will have a slope of 90 minus 50, 40 by 3. C will have a slope of 90 minus 50 is 40, but because in this case partial crashing is not allowed, so this means this will be 40 minus 40, but that will be for 3 days. Okay, D, it is 20, yes, 20, but this will be for 1 day, and E, it is 100 minus 40 is 60. 60 divided by 2 is 30 minus 30. So, but in this case, partial crashing is allowed. Okay, so this is the cost slope. Okay, so now what I want is to reduce the duration. Okay, so in this case, as you can see that A is a non-crashable activity, so maybe it's better for me to just cross this out. Okay, A. Okay, and the duration depends on this path. This is the longest path, and now A is out of the equation. C and E are the candidates. C is 40, but that is for 3 days. We don't need to reduce the duration by 3 days. We only need to reduce the duration by 2 days. And even if we choose C, then its duration will be reduced by 9 days, and then with that now because it will be 9 days, so this is 11 days, so we have to reduce duration from here by 1 day, from maybe for B or E, like that. So it will be a costly option. The other option which I am going to use now is E. Okay, if I reduce the duration E, so it will take 30 extra, so reduce E by 1. Okay, so E minus 1. So this AD will remain 9 because there is no E here. E was reduced by 1 day, so this duration will become 11, and E was reduced by 1 day, so this duration will become 10. Okay, still the length of the critical path is 11 days. AC is still the critical path. A can be reduced for 2 days, so there is still a 1 day of crash available. So again, we will choose E because this is the cheapest available option. C is not the option because C have to be combined with some other activities and the cost will increase because C is already 40, and then if you add 30 with that, then that will become more expensive. So I will choose E again, so it will remain 9. It will yes, it will become 10 E, and then it will become 9. So now the objective has been completed. The objective is to reduce the duration of the project in 10 days. And how did we do it? What we do is we reduced activity E by 2 days. So reduce E by 2 days. And with the additional cost, what will be the additional cost? From 40 to 100, that means 30 each time, 60 additional cost. So additional cost will be 60 plus $60. That's all. That is what we wanted to